This is Numbers with Nicole, and I'm going to model some problems where we find the missing angle of a right triangle using inverse trigonometry. I made a video before this one that you should have viewed explaining inverse trigonometry and what I mean by that. So find the degree measure of angle P and angle Q in the right triangle below, round both to the nearest whole degree. So we'll focus on angle P first. I have all the sides of this right triangle, so in order to find the angles, I would have to use some kind of sine, cosine, or tangent. So I'm going to write my acronym SOHCAHTOA. All right, so I'm going to use angle P. Since we have all the sides, really we could use any of the sine, cosine, or tangent, but I'm going to just pick one to go with. All right, so angle P will be in this orange color, I guess. And so in reference to angle P, so sine of angle P would be equal to the opposite over the hypotenuse. So for angle P4 is the opposite, and for the triangle, the hypotenuse is 5. That is not going to change. All right, so again, we can't divide by sine. We can't divide by sine P to get P by itself. The only way to get the angle P is to use the inverse sign, which is that sine, or the arcsin, which is that sine -1. That is the only way to undo sine of an angle, is to use the arcsin. So in that arcsin, I put the ratio and I go over to my calculator. Second sine, 4/5. Enter. So about 53 degrees to the nearest whole degree. So we could now subtract 53 and 90 from 180 to get angle Q, but since I'm modeling how to use trigonometry here, I'm going to do it using trig. So I'm going to use angle Q will be in green. And so that's going to have different opposite and adjacents. The hypotenuse will still be the same. So I'll use tangent for angle Q. So the tan of angle Q, the tangent of angle Q will be the opposite, which for Q would be 3, over the adjacent, which for Q would be 4. Okay, so again, I can't divide by tan. I can't divide by tan of Q. I have to use the arctangent. So angle Q will equal the arctangent of the 3/4, that tangent ratio. And that's, again, something we put in our calculator. Second tan, 3/4, enter. We get approximately 37 degrees, which makes sense. Angle Q plus angle P should be 90. So again, we're going to do one more model, a little bit different here. We're not given the 3 sides. So you could find the third side using Pythagorean theorem and then use whichever trig ratio you want. That seems like a lot of work when we have 3 options available. All right, so we want to find angle A. I'm going to mark angle A, make it clear, make it stand out. I see that I have the opposite and I have the adjacent. So the opposite and adjacent means I would use tangent of A would be 11.2 the opposite over 18.3 the adjacent side. I cannot divide by tan of A. I cannot divide by tan, so I know that angle A will equal the arctan of that ratio that I wrote, 11.2 over 18.3. All right, so we go to our calculator. Second tangent, 11.2 divided by 18.3, enter, and we get that angle A to the nearest tenth is 31.5 degrees.